Hello, my name is Sherry Hughes, and this is instructional video explaining the concepts learned in Statistics 2 using SPSS and the data provided. SPSS calculates measures of central tendency and dispersion very easily, and it also generates graphs that can be copied and pasted into different documents. Today, we will navigate through SPSS. When you click on the data set, you have two views. The data view here is where we enter our actual data, the numbers and for height and weight, and then we have the variable view. Variable view is where we give our data names. It's very important to do that so when you have your data output, it's easy to read and to understand. So today we have a sample size n equals 271, and we are going to analyze some descriptive statistics. So we go to the top, we're going to click on Analyze, Descriptive Statistics, Frequencies, and we are going to click on some of our variables. So we're going to start with age, move it over, and then we are going to click on how many hours of sleep. How many hours of sleep? Click there. Next, stick on the Statistics tab, and we're going to click on Quartiles. And we're going to click on our percentiles, as standard. We're going to do 25%, and then we were going to do our 75%. We're also going to click on mean, median. We're going to click on mode for frequently occurring. And then we're going to go down to dispersion. We will click on standard deviation. We're going to click on variance to find out how varied our sample can be. We're going to click on range, minimum, maximum. We're also going to click skewedness. After that, we select continue and OK. Here we get measures of central tendency. We can see standard deviation of 12.684. We can also see our range, which would tell us if we have any outliers. And we also see the skewedness of the data as well. So let's say we wanted to create some charts of our variables and get an idea of what our data looks like graphically. We click on Analyze, Descriptive Statistics, Frequencies, and this time we click on charts. Now since we have continuous data, we can select histograms. Otherwise we will select bar or pie charts. Again, continue. Okay, I'm going to scroll down a little bit. And here we have pretty much a look of what our data looks like. A fairly nice curve here in terms of age. And then we go down here. Hours of sleep is also pretty nice. A good average of our curve, but slightly skewed too. In the next test, we will measure one group against another to see if there are any statistical differences between the two. Now, because each of the groups are independent of each other, we will use an independent samples t-test using the same data set. We will go to Analyze, Compare Means, Independent Samples t-test. Now here, the first thing we need to do is the variables we will measure. So let's move to satisfaction of sleep. Let's find that. Satisfied with sleep will be our test variable. And then we want to compare another group. So we're going to look for smokers. Do you smoke? I'm going to move that down to our grouping variable. Notice that we cannot click OK. SPSS wants us to define the groups. Group 1 will be 1 for yet no smoke. Group 2 will be 2 for yes smoke, or actually vice versa. So we're going to click on OK. Now here we have our groupings. Our output opens and we can see there's a slightly difference between the two means of the groups. Those who do smoke are at a 0.506 for satisfaction with the amount of sleep, and those who do not smoke are at a mean of 5.61 for satisfaction in the amount of sleep. But what we want to know is, are these differences statistically significant or not? So we move to our independent sample t-test, and we look at the results of our Levine's test of equality of variances. Now the decision or the rule of thumb is, if our p is less than or equal to 0.05, the variances are statistically different, and we want to interpret the bottom row. However, if our P is greater than 0.05, the variances are not statistically significant, and we want to interpret our at the two conditions. Which does ours fall into here? Well, we have a p-value of 0.617, so therefore it falls into the second condition here. P is greater than 0.05. We interpret the top row. We look at our p-value, which is 2.232, which is greater than 0.05 level of significance, which indicates our mean differences are not statistically significant for the smokers, non-smokers groups in terms of satisfaction with sleep. Therefore, we can say there is no statistically significant difference between the satisfaction of sleep between smokers and non-smokers. P equaling 0.232, our degrees of freedom at 265, and our sample size of 2. We will use is called Pearson's R. Pearson R measures the linear relationship between two variables. R means regression. By linear, we mean the relationship that can be well characterized by a straight line. We will look at the relationship between caffeine, how many caffeine drinks, and the time it takes falling asleep. We will be using the Pearson product moment correlation coefficient, and preliminary analysis will be determined and conducted to ensure there is no violation of normality, linearity. So what we will determine here is if caffeine affects the time it takes to fall asleep. Essentially, we hypothesize that the higher the amounts of cups you have, the longer it will take to get to sleep. So our question would be, what's the correlation between caffeine drinks and trouble falling asleep? So we will go to analyze. We will go to correlate, bivariate. We want to move our two variables over. How many cups of coffee? We'll start there. Let's find that. How many cups of coffee? And also trouble falling asleep. Let's find that. Trouble's falling asleep. We're going to put that there also. Okay. Now, SPSS assumes by default that we're going to use Pearson, and they also will flag the significance of the correlations by using 2 asterisks if there is any significance. Click OK. And then we have our correlation box. Here we see a matrix. Now here our correlation coefficient is, or R, equals 0.046. We have a significance, and let's just look right here. We see these numbers right in here are identical to these. What that tells us is that how many cups of coffee or caffeine drinks per day, 0.046, is also equivalent or equal to the same amount of trouble falling asleep at 0.046. So we have a correlation coefficient, or R, equals 0.046, and our level of significance at the 459. Therefore, we can determine that there is a moderate, positive, significant relationship between the amount of caffeine and time it takes to fall asleep, where R is equal to 0.046, our N equals to 260, and P is greater than 0.05. Now I will demonstrate how to perform a one-way ANOVA in SPSS. The hypothesis is that 4 different groups of people who are married differ in hours of sleep needed. Our null hypothesis, there is not significant difference in the number of hours of sleep for the 4 groups. So we will click Analyze, we will click Compare Means, and then we're going to go on to one-way ANOVA. Here we're going to choose our marital status is going to be our factor, and our dependent variable, which is going to be how many hours of sleep. Let's find that. How many hours of sleep? Let's find that. Here we go. How many hours of sleep will be our dependent variables. Now we're going to go in options, and we will choose descriptive, homogeneity of variance. We will also select Browns-Forsyth and the Welch, and then we will click continue. I'm going to click. Oh, our factor just disappeared. We click OK. And then we have our descriptive statistics. We have here, we see the means of the married, single, divorced, widowed. We also have the standard deviations, which is some of the most important information. Again, single, married, divorced, and widows. In SPSS, they also give you a test of homogeneity of variances. And ANOVA test essentially is an analysis of the variances or an analysis of these means. And basically what it really is doing is it's examining the variability amongst the means and comparing against variabilities within each means in terms of the individuals in the group, and that's why it's called analysis. So the ANOVA table tests the hypothesis that the four means are statistically different. Here we have in ANOVA, our F value is equal to 2.494, which is not statistically significant at the P is greater than the 0.01 significant level, where our P is equal to 0.060. But we look at the homogeneity of variances, and they confirm that there is statistically no significant difference from each other. And then this is why SPSS gives us the robust test of equality of means, which again here, it confirms that there's no statistical significance between the means. P is greater than 0.01. And therefore, these tests back up our significance. Therefore, we fail to reject our null hypothesis and are confident that there is no statistical significant difference in the means of the groups. And if we plot these, we will see that they go into the direction that we expected. We're going to go into graphs. We're going to go to chart builders. Click OK here. And we are going to select this. We're going to scatter dot. We're going to select here. And we will select our variables. We will drag our scatter plot here. We will then select our variables, marital status. We can drag that here. And then how many hours of sleep? Let's find that. How many hours of sleep? Go here. I'm going to drag that here. Then we're going to just click marital status. Drag that here. We click OK. And we get a nice scatter plot, which shows here and confirms no real statistical difference between single, married, divorced, and widowed. However, married does have one outlier. And that concludes our statistics 2. Thank you.